So, 6-4. I think we will have a... Did I say we're having a quiz? I can't remember. When's the quiz? What is it? Wednesday? Yeah, there you go. Yeah, so we'll probably take 2 days on this. I don't know how much. I might be able to finish teaching this lesson today. We'll see. But we have tomorrow too. I gave myself 2 days for this lesson. So there are 3 different things to cover. So we will have a quiz on Wednesday. All right, let's do this. Well, you know what 2 of these words are, right? You know what a rectangle and a square is. What in the world's this word? Well, it's a rhombi. I haven't even said rhombi before, I don't think, have I? It's a type of rhombus. Look what this says. This says rectangle what? Rectangles. Very good. This is square what? So this is plural. So what do you think rhombi is? It's plural. Now these are all plurals. Why would that be singular if that's a plural and that's a plural? So this is a what? It's a plural. What does the plural mean? It means more than one. Okay, more than one what? Rhombus. Okay, and this is how you spell rhombus. All right. So these are just all plurals, rectangles, squares, rhombi. Okay, it's just how they make rhombus plural. So that's all it's talking about. All right, let's start with rectangle. We already know what a rectangle is, but we're going to talk about some special stuff about a rectangle that we didn't know before. All right, we know a couple things about a rectangle that is special. First of all, just by the definition of a rectangle, what do I know about this? It's a what? It's a quadrilateral with what? 4 right angles. Very good. All right, so this is a right angle. That's a right angle. That's a right angle. And this is a right angle. So it's a quadrilateral with 4 right angles. All right, that's by definition. I don't think we've learned anything else, have we? Well, we know it's a parallelogram, right? Okay, so it's not just any quadrilateral, it's a parallelogram with 4 right angles. I should have said that. So if it's a parallelogram, what else do we know about it? It's just since it's a parallelogram. The opposite sides are parallel. Good. What did we learn in, I think it was section 6.3? Let me take a peek. Yeah. Well, it was actually 6.2. I think. Let me double check. Yep. It was in 6.2 we learned something else about this if it's a parallelogram. If it's a parallelogram, we know that the opposite sides are also... Oh my goodness. Guess I'll have to pause this thing. How do you pause this? There it is. All right. Fun fire drill. Let's see what else we were talking about here. Where did we leave off? Okay, we said that the opposite sides are equal to each other, so we know all that stuff. So this is all old stuff, okay? It's nothing new. What else do we say? We said something about the diagonals of a... oops, I'll just keep it white. We also said something about the diagonals of a parallelogram. What was true about the diagonals of a parallelogram? What did they do? They bisect each other. That's right. Okay, so the diagonals of a parallelogram bisect each other. But this isn't just any old parallelogram. Now we're getting to the new stuff, right? So this thing that I'm doing right here is new. Let me put some letters in here. Let's go A, B, C, D. So everything we've done up to this point has been old. We said the diagonals bisect each other, the opposite sides are equal, the opposite sides are parallel, and you got 4 right angles. So all that stuff we already know about a rectangle. Okay, there's only one other thing that we're going to learn about a rectangle. All that stuff is true, except for the right angle thing. All the other stuff is true because it's a parallelogram, all right? Not necessarily because it's a rectangle, because the opposite sides are equal on any parallelogram. Doesn't have to be a rectangle. The opposite sides are equal to each other because it's a parallelogram. The diagonals bisect each other. Why? Because it's a what? Parallelogram. All that stuff is true. The only thing that's specific to a rectangle is that all 4 angles are right angles. Everybody with me on that? Okay. But there is something else that's specific about it being a rectangle. Let me change the colors of these. I'll show you why in a second. Okay? All right. So we know that the diagonals bisect each other, but because it's a parallelogram, the fact that it's a parallelogram, I'm sorry, I misspoke. The fact that it's a rectangle, okay? The fact that it's a rectangle means that the red one and the blue one, what do you think? Just look at them. Look at the lengths of the red one and the blue one. What does it look like? Might be true. What is it? Well, we already said they bisect each other because it's a parallelogram. But what kind of extra thing do you think is possibly true? I heard it a couple times. What is it? That they're equal to each other. Exactly right, okay? If it's a rectangle, all right? So what we're going to do is say this. The diagonals of a rectangle. Now remember, I'll say it again. All right, it's worth repeating. The diagonals of any parallelogram bisect each other, correct? All right, so that's true here because this is also a parallelogram. But what's specific, what's unique about a rectangle is that the diagonals don't just bisect each other. What are they? They are equal, or a lot of times we say congruent. All right, so that's really important. Are the diagonals equal to each other, congruent to each other on every single parallelogram? No. Only when that parallelogram is a what? What do we got here? What do we got in front of us? What is it? It's a rectangle, okay? And it says it right here. The diagonals of a rectangle are congruent to each other. If I just had an everyday parallelogram and I drew my diagonals, are those diagonals congruent to each other? No. Only when that parallelogram is a rectangle are the diagonals congruent to each other. All right, so that blue one and the red one are congruent. Instead of saying blue and red, all right, you're not always going to be able to write in blue and red. I actually always carry around a blue, red, and black pen with me all the time. You know why? Well, red, because every teacher's got a red pen, right? Because I mark all the problems right or wrong with red. Why do I carry around a blue? Anybody have any idea? You probably have no clue. In the grade book, here, I'll show you. Not that this has anything to do with the lesson, but I'll show you anyway. So if you look at my grade book, you probably can't tell very well, but all the homeworks I put in black, all the tests I put in red, and all the quizzes, what do you think I put the quizzes in? Can you tell? It's in blue. It's in blue. All right, anyway. All that just because I said you probably don't have a blue and a red pen on you, but I always do. Anyway, what's true about the blue one and the red one? They're equal to each other, but let's not call them blue and red. Let's name that red one. What would I name that red one? Line segment what? Come on, what's the red one? Look at it. Everybody should be able to tell me this. You should just walk out right now if you can't tell me what the name of that red one is. It's BD. All right? So, line segment BD is congruent to what? Okay, CA or AC. It doesn't make any difference. Since you said CA, I'll put CA. It doesn't matter the order that you put this in. So, if it's a rectangle, remember, it has to be a rectangle. If it's a rectangle, then the diagonals are congruent to each other. Let's put an E right there. Now remember, the diagonals also bisect each other, correct? So that means, let's do this in a different color. That means that AE equals EC, and it also means that BE equals DE. But since the two diagonals are exactly the same, and they're both split in half, what do you think is true about BE and ED? They're equal. But guess what else is true? AE and EC are equal, but all four of those are equal to each other. So if I said that the length of BE was 5, what would the length of EC be equal to? That's also 5. That's the first time we've done that. Because over here, what if this little bit was 5? Does that mean this thing from there to there is also 5? No, not at all. Okay, because those are not equal. But here, on a rectangle, all four of these segments from BE, CE, DE, and AE, all of those are exactly the same. All right? That's the only time we've done that. It's the only time we're going to do that, okay, because it's a rectangle. So the diagonals bisect each other, and the diagonals are equal to each other. So if I split two equal things, both of them in half, then every part, every one of those halves are going to be the same. So if that's 5, that's 5, that's 5, and that's 5. You got me on that? You know what they're going to do, though, don't you? Instead of making this 5, or maybe instead of making this 5, what would they do? This is like x plus 2 or something like that. And then you got to solve for x. What would you do? You'd set them equal. You with me on that? Or they might not tell you this is x plus 2. That's too easy because you know they bisect each other. They might tell you this one is like x plus 2. All right? Everybody with me? And what do? You set them equal. X plus 2 equals 5. Subtract 2 from both sides. So x is what? 3. You with me? Yeah, you know they're going to do stuff like that. All right. Well, let's do one like that. Since we just talked about it, they have an example that is pretty much what I said. But let's do the actual example in the book. All right, so this is straight from the book. If you look in the book, you'll see it. JKLM, JKLM. They tell you that this is a rectangle. So if they tell you it's a rectangle, you know a bunch of stuff about it. You know that all the angles are equal. And you know the diagonals are also equal to each other. That's what we just finished talking about. So the diagonals are equal. They also bisect each other, which means all the stuff, these two parts, JN, KN, LN, MN, they are all equal to each other as well. So here's what it says. They tell you that JL is equal to 5x plus 2. They also tell you KM. KM is 7x minus 6. And they want you to find MN. Okay? So how would you approach this? They tell you this stuff, don't they? They tell you that JK is 5x plus 2. So what are you going to do with the picture? Well, first of all, let's put them on the picture, okay? So JL, where's JL? JL is this whole thing, isn't it? So it's this whole thing right there. That's JL. That's 5x plus 2. We good? They make this super easy, actually. I thought they were going to make it a little bit harder. They make it really easy. And then they also tell you KM. All right, so I like to look at it first before I decide, do I set them equal to each other? Do I add them up and set them equal to something? What do I do? Well, I got to look at my picture. So look what they give you. They give you this diagonal as 5x plus 2. They give you this diagonal as 7x minus 6. So what do I know about those two diagonals just from this first part of the lesson? What do I know about the diagonals of a rectangle? They are what? They're equal to each other. So Zion, you said it earlier. So what do you do to these two? You set them equal because they're both exactly the same. This is one diagonal. That's the other diagonal. They're both exactly the same, so you set them equal. So here we go. When I set stuff equal, I like to have the bigger one, the bigger x on the left-hand side. It just makes it a little bit easier to keep the x on the left. And then that's equal to what? 5x plus 2. So we got to solve for x. So let's do the math. We've done this a million times. Maybe not quite a million, but it seems like it. And then you add a 6. That cancels, that cancels. 7x minus 5x, 2x. Then 2 plus 6, 8. Last step, divide by 2. X is 4. Is that my answer? Do I circle it? No, because they ask you to solve for MN. So look at MN. What I'm going to do is this. Now watch very carefully. So this is what you're trying to solve for. This thing right there. I'll put a question mark, okay? Everybody with me on that? So MN is half of MK, right? So what I'm going to do is I'm going to find MK or KM. So let's plug X back into this. So it's 7 times what? 4 minus 6. 7 times 4 is 28 minus 6. What's 28 minus 6? 22. Is that my answer? Is that MN? That's right. I just found that whole red one right there, KM, didn't I? Which is 22. So what is MN compared to the whole thing? It's half of it. So what's this little green one right here going to be? That's right. It's 22 divided by 2, which is 11. So that's MN right there. So MN is equal to 11. Yeah. Into the what? You could have, yeah. It wouldn't matter. I just did KM. I thought it would make it not so confusing because you're putting it into that whole entire diagonal that one's a part of. But yeah, you could have put it into the other one too. Like if you like 5x plus 2 better than 7x minus 6, it's perfectly fine. Let's just see if it works. Put an x in for this x right here. 5 times 4 plus 2, what does that give you? Oops, I got ahead of myself. Plus 2, what's that? That's 20 plus 2 is 22. So the yellow one's also 22, isn't it? All right. But all of these, this one, this one, this one, and this one, they're all equal to each other. So if this one was 11, then what's KN? 11. What's NL? 11. What's JN? That's 11. Everybody got it? All right. It's not too hard, is it? Again, haven't we kind of been doing the same thing all year long? Except we just do it with different figures, right? We just do it with different shapes. But it seems like they put in some variables in there, we set them equal to each other, or we add them up and set them equal to something. Then we solve for x, then we plug it back in, and bam, there's our answer. We've been doing that all year long. If you go back and watch one of my old videos from the very beginning, I think I say that too. I'm like, when we first solved for x, right, and plugged it back in, I'm like, see what we did right here? We're going to be doing that the rest of the year. Was I lying? Nope. We have been, haven't we? We've been doing that all year long. Now, if you just walked in the door and saw all this mess, you're like, oh my goodness, what's going on? But if you took it little step by little step, it was actually pretty simple. Okay? It wasn't much different than we've ever done. All right, let's do rhombus. We'll do an example with a rhombus, and I think that's where we'll end it. Okay? Because I got too much to do to try to fit it in just a few minutes. Since we had that lovely fire drill. All right, let's do another one. Let's talk about a rhombus this time. So let me try to draw a rhombus. All right, and I want to slant it. I mean, technically that is a rhombus. If that's a square, isn't a square a rhombus? Yeah, because it's got 4 equal sides, doesn't it? But usually when they show a rhombus, they usually slant it a little bit. And let's pull this up a little bit so it looks like all the sides are equal. That looks pretty close to a rhombus. All right, so what we're going to do, we're going to talk about the diagonals. Let's make it red. We're going to talk about the diagonals again, but there's 2 things that are true about a rhombus, the diagonals of a rhombus. First of all, are they equal to each other? Why not? The diagonals are only rhombus. The diagonals are only equal to each other when it's a, what do we just do? Now, listen to me. The rhombus, or the diagonals, are only equal to each other when it's a rectangle, when the diagonals are the diagonals of a rectangle. This is not a rectangle, so the blue and the red one do not equal each other in this situation. Everybody see that? Because it's not a rectangle. What if it was a square? Would the diagonals equal each other if it was a square? That's a great question. That's the question you need to ask. Isn't a square a what? A rectangle. Yeah, the square is a rectangle. So what's true about the diagonals of a rectangle? They're equal. So what is true about the squares of a square? I'm sorry. I'm getting all my words mixed up. What's true about the diagonals of a square? They're equal to each other. But the diagonals of a regular rhombus that doesn't have right angles, those are not equal to each other. That blue one looks way bigger than, well, not way bigger, but a little bit bigger than that red one, doesn't it? Yeah. All right. So they are not equal to each other, but they do something. They do 2 things. All right. I'll show you the first one. I'm going to go out of order. All right, the first thing that they do is look at the angle that they make. Those two, that red one and that blue one. Do you see the angle that they make in here? See this angle? I shouldn't do it like that. See that angle right there? What does it kind of look like? What kind of an angle does this look like? Well, we got vertical angles, that's true. This angle right there looks obtuse. I don't know. I don't know what you're looking at. I think that looks like a what? It looks like a right angle. And guess what? It is a right angle. Okay? It is a right angle. So, look at this. That's the only time that happens. It doesn't happen with a rectangle, with a regular rectangle. Look at this. Look at that. I know it's a mess in here, but look at this angle right there. Does that look like a right angle? Does that look like a right angle? No. So if it's a rectangle, there's no way that they make a right angle. But this isn't a rectangle. What is it? It's a rhombus. Let's write that down. Should have written it down. All right. So this is a rhombus, which means what's true about a rhombus? All four sides are equal to each other. Okay. Now the diagonals do bisect each other. That's true. All right. But what's special today? What's new today that we never learned before about the diagonals of a rhombus? They are what? Perpendicular. So let's write that down. So the diagonals, there's two things we're going to learn. This is the first thing. The diagonals of a rhombus are perpendicular. What does that mean, perpendicular? It means they make a what kind of an angle? A right angle. All right, so they are perpendicular. So a rhombus, the diagonals of a rhombus form a right angle. You got to go to the bathroom. Jeez. All right. So tired of signing bathroom passes. All right, what else was I going to say? Okay, so that's one thing we know, all right? Which means we have a right triangle. We won't even talk about that, but we do know we have a right angle, all right? Here's another thing. I'll keep the same picture, all right? And we'll do it in yellow as well. So we also know, and this is new. This is brand new. We didn't know this before, okay? But we know on a rhombus, this is only true about a rhombus, but on a rhombus, the diagonal bisects the opposite angles. Okay? You hear what I said right there? The diagonal, that blue one, bisects this angle, which means that this angle and this angle are equal to each other. So what if the whole angle was, 60 degrees? What's that little tiny angle right there and that little tiny angle right there? They're both 30, exactly. That's 30 and that's 30. So if the whole angle is 60, these two are 30. Right? That angle could be anything, all right? But how do you find the two? It's bisect, it's half of it. Now, we learned something else about a parallelogram and opposite angles. What's the old thing that we learned? That the opposite angles of a parallelogram are what? Are equal to each other. So, if this whole big angle right here is 60 degrees, what's this whole big angle right there? That's also 60 degrees. So, if that's 60, this diagonal also bisects this angle. So if one of those angles was 30, watch this. Let's get rid of some stuff here. Let's get rid of all this, get rid of this, and we'll get rid of that. Right? What if I told you that that angle right there was 30 degrees and this was a rhombus, and that's all you knew? I could automatically tell you what this little angle right here is. What would that be? That'd be 30. I could also tell you this angle right here, or here. This would also be 30, and this would also be 30. You guys aren't even paying attention, not even looking. At least your heads are off the desk. That's good. Okay, except for one. Two, he's on his book bag. All right. But let's watch. Let's look up here. Let's look at this and pay attention, okay? You might learn something. Now, who knows? So these two angles right here are equal. These two angles are equal to each other. Now, just knowing that angle is 30, I could tell you all of those angles. I could also, with the information that we have known before, I can also tell you what this angle is equal to. How would I do that? Well, what's this whole big angle right there? What's this? They are. What's this whole big angle right here? That's 60. So what's this whole big angle right there? It's 120. That's right. Everybody see that? So that's 120 because, Zion said it, they're supplementary to each other. That's not new. That's old. Okay? We knew that from before because we know that the parallelograms, the consecutive angles of a parallelogram, are supplementary. So if this whole thing is 60, then this whole thing is 120. So what's this little angle right here going to be then? Remember, the whole thing is 120. What do we say about the diagonals of a rhombus? What do? They bisect the angles. Yes, now I heard it. All right, so the whole thing is 120. So what's this little angle right here? That's 60. What's this little angle right here? What's this one? What's this one? Okay, you got it. All right, put little angle symbols there. So just knowing, look at this, just knowing that one little angle right here and that you had a rhombus, we figured out every single angle in the rhombus with all these diagonals. We know this is 90. So what's this angle right here going to be? That's going to be 90. That's going to be 90. That's going to be 90. So look, 90, 90, 90, 90, 60, 60, 30, 30, and so on. You know every single angle inside of that. Just by knowing that what? It's a rhombus, and you know just one of these angles. So that's pretty cool, I think. All right. Maybe you do, maybe you don't, but I think it's kind of cool. All right, so let's copy this. Let's do an example, and we will be finished. All right, so there's our rhombus. We're going to put a couple diagonals in there. There's a diagonal. There's a diagonal. And let's label it. I'll use the same letters they do, A, B, C, D. And they put, see what else they tell you. They tell you it's a rhombus. And they ask you for a bunch of things, but I'm going to label some things first. So this is angle 1. This is 3. It's not 3 degrees. It's just the name of the angle, okay? It's called angle 3. Everybody with me on that? This is 2, angle 2. Now this one they do tell you the degrees. That's 34 degrees. And this is angle 4. And I think that's everything. And again, they tell you at the very beginning that this is a rhombus. So you know a lot of stuff about it. You know the opposite sides are equal. Okay, you know that, well, actually, you know all 4 sides are equal. You know the diagonals bisect each other. You know the diagonals are perpendicular. You know the angles are being bisected. There's a lot of stuff you know already about a rhombus. So here's what they're going to do. They're going to ask you a bunch of questions. Let's write down the questions. In fact, I think there's 6 of them. They ask you 6 different things. All right? Oops. Angle 1, they want you to find angle 1. They want you to find angle 2 and angle BAD, that bad angle right there. Angle BAD. They want you to find angle 3. They want you to find angle ABC. They're kind of needy, aren't they? They want you to find all kinds of stuff. All right. So this is the stuff that they want you to find. So let's do it. Let's go different color. All right. All the red stuff is the stuff they gave you. And you know it's a rhombus. So what about angle 1? Angle 1, you should be able to do angle 1 without any math at all. How much? 90 degrees. That's right. Because if it's a rhombus, the diagonals are perpendicular. So you know that angle right there is 90 degrees. What about angle 2? Again, without any math at all. How do you know it's 34? Because that diagonal does what? Well, the diagonal does what? It's not opposite. It bisects that angle. That's right, which means these 2 angles are equal to each other. So if that's 34, without doing any math at all, angle 2 is what? 34. Where's BAD? BAD is this whole entire thing. How'd you get 68? Add the 34 and the 34. But that's that big angle C right there. I want to find this big yellow one right here. Big angle A. Is it? I didn't really draw this to scale, okay? Because if that's 68, it looks... Now look, are you listening to me? I don't think I drew this to scale, all right? Because if this whole thing is 68, that looks like an obtuse angle. It doesn't look like a 68-degree angle, does it? All right, but let's just go by the numbers. Don't go by what it looks like, all right? So if that's 68, what's this whole big angle up here? That's also 68 because the opposite angles are equal to each other, all right? So angle BAD is also 68 degrees. You see it? 34, 34, which means that's 68. If this angle C is 68, this big angle A is 68 as well. What about angle 3? Yeah, really, no math involved, correct? Because you know that these four, this one, this one, this one, and this one are all the same. So that's got to be 34 as well. Or you could have said the whole thing was 68, and this is half of 68, couldn't you? It's a lot easier just knowing that all four of them are equal. So that's 34 as well. Look, what's the only math we've done up to this point? What's the only math we've done? Just 34 plus 34. That's all we've done, okay? ABC, where's that? ABC. Let's do that in a different color. So ABC is that big angle right there. Remember, this whole thing was 68, correct? Right. So how do you find this one right here? Now you do have to do some math on this one. What's the math? 180, what? Minus 68. And that's 112, right? Yep. So that whole thing right there is 112. So that's ABC. And angle 4, how do I find angle 4? Half of 112, right? Okay. If you didn't have a calculator and you need to do half of that, you do this. How many times? 5. Remember this? Okay, that's 1, 2. What's that? 6. So what's half of 112? 56. So angle 4 is 56 degrees. And there you go. You found them all. It's definitely something you can see on a quiz or a test. I would not give you like all of these as one question. I might just ask you to find, maybe this angle and this angle or something like that, okay, on a quiz or a test. Wouldn't ask you for all 6 of them, but it's important to be able to find all 6 of them. All right. There's a few things that we didn't go over. So let's see. What did I say on the lesson plan? Let me look at it. Yeah. I'll probably have to finish a little bit of this up tomorrow, but try to do as many as you can. We're doing 1 through 11, and it's section 6-4. Okay, so there's your homework. There may be a few at the end you can't do, but you should be able to do most of 1 through 11. It's not that much to ask. Okay.